So first of all, what is OnMetal? So we used to call it Project Teeth. So if any of you work in this area, maybe like a startup, you may have had some guys come by last summer, fall, and kind of ask, what do you want in a server? What we realized is that like the cloud is not doing it for a lot of you. And we came up with this idea, we're going to give the cloud teeth. We did, and we called it Project Teeth. And that's what turned into OnMetal. And the short of it is that it's new cloud servers flavors. So Rackspace Cloud is our kind of cloud offering. The central thing is the compute. And that is today you can have all of those except for the ones that say OnMetal kind of in front of them. And they're just virtual machines. It's kind of similar to what you get with Amazon or Google or some other cloud provider. So the way this is different is that it's bare metal. So we're targeting kind of people who are running software at scale, mostly internet applications. We're not a lot of it's not some kind of internal IT app or whatever. This is mostly customers who are running very large kind of internet applications. And this is maybe controversial, but people who are outgrowing the cloud. I'll come back to that in a moment. And maybe people who are considering co-location or have co-location and hate it. And it turns out that's a ton of people too. So the idea of outgrowing cloud is controversial, but there are a lot of things that actually cause this to happen. So performance on cloud is very variable. Maybe it's great, but maybe you don't. So there's a lot of people doing things like booting servers and then killing them, measure it. Is it good? Is it not? I have no idea. Sometimes your instances get retired. You were deploying all in this one specific instance type, but now that instance type is gone. What are you going to do? You end up deploying lots and lots of small instances instead of just kind of scaling vertically as long as you can. So especially for younger companies who are trying to grow quickly, instead of focusing on delivering your actual product and writing software, you're focusing on how do I scale this giant cloud thing. And then there's hypervisor overhead. And so this depends a little bit on what you're doing. Some applications it's not a lot. On others, especially things that are I/O bound or doing a lot of context switching, there's actually a lot of overhead in hypervisors. This is something that we think is going to go away over time. It's a problem today. In 10 years, who knows, hypervisors are going to be good. The amount of money that people are investing in making hypervisors better is completely ridiculous. And I would love that to stop. But the other thing is that when you're using a cloud, you're kind of sharing the network. Because you're sitting on the same machine as the thing I'm running, and you probably don't want to know what I'm doing, but it uses a lot of bandwidth. On the other hand, the other option people are kind of investigating is co-location or even kind of go it yourself, do I build a data center? And all of that is horrible. So I spent the 2 years prior to working on OnMetal building a product internally here at Rackspace called Cloud Monitoring. We're a large kind of at-scale monitoring system. And even working at Rackspace, and we're a hosting provider, getting hardware is painful. And it's not it doesn't necessarily have to be that way, but it turns out that how do I get a server from Asia into a data center wired correctly, hooked up there's some guy has to station to a switch and do something. That's how networks work these days. I need to kind of project the costs, because instead of just paying by the month or hour like we are today, people doing colo are buying servers up front and they expect these things to last for some predefined period of time. I don't know how long that is. And I shouldn't have to know. So the idea of OnMetal is to sort of give customers the best of cloud, which is that elasticity, the idea of not having to worry about how much am I spending on buying a server today, how long is it supposed to last. We want you to be able to boot a server, get it quickly, have it behave kind of like a cloud server from the how do I get it perspective, but behave like bare metal in a colo from the do I have a good server? Is it do I need to kill this server? Of course not, it's just a server. The other thing we're doing is opinionated flavors. And so this is where the Rackspace cloud today is kind of is it little or is it big? And they're just kind of big or small. And you'll see the same thing with DigitalOcean or some other providers. But Amazon has memory intensive or compute intensive. This is our first kind of foray into that. You can get a memory intensive OnMetal server. I'll go into that more in a few minutes. And my favorite part is that there's kind of a do-it-yourself option. So this is all built on open compute hardware. So you can call up our supplier in Asia. You're going to have to buy quite a bit of it. There's some kind of middlemen who will make this easier for you. But basically, if you want to, you can call up, buy the exact same servers that we're running. We'll tell you what they are. And you can run the exact same software. We blogged about how to deploy it. It's all open source. It's mostly based on OpenStack. So one of the questions that I get a lot is do you hate virtual machines? Because I'm up here talking about like the death of virtual machines. And it turns out there are fundamentally two things that people do with virtual machines. So the first of these is resource sharing. I want to get one of those. I have no idea where. But this idea of, like, I mentioned that, like, sometimes you have to buy a server up front. When I buy a server up front, if I am in fact, like, I don't know, working in some like IT thing in the basement or whatever, sometimes buying a server up front to host some little bitty thing doesn't actually make a lot of sense. And on the other hand, maybe like running it like distributed across a CoreOS cluster might not make sense for some applications either. So this idea that I dice up my resources and kind of share them, it makes sense. The other interesting thing is that like I don't necessarily have to take a server and chop it in two in the sense of like half memory goes to this server and half goes to this server. You can also do things like chop it in time. So if anybody saw AWS announced a new instance type this morning where you can kind of burst CPU an awful lot. So there's interesting things you can do with hypervisors with resource sharing. And for some applications that makes a lot of sense. The other thing we see people doing is using virtual machines as an architecture primitive. So they say, I have a web application, we're going to stamp out 12 of those, and then or there's like a database node, we need some of those, right? My Cassandra cluster is scaling up or whatever, or maybe I can't even scale it, who knows? But so we're using virtual machines as a way to kind of wrap up an application and then stamp out instances of that. My kind of theory on that is nice try. Like Amazon introduced this as a concept that became very popular in like mid-late 2000s. And today, that's like how people do things. They have entire things about how do you template out more servers around this. And it was cool, like this idea of we're going to have kind of this like write once, deploy anywhere. We'll just like stamp out more web nodes. That sounded great for a little bit. But it turns out there are some fundamental problems there. And so containers are kind of coming along and solving these problems for a lot of us. So I'm contending that containers are kind of the new deployment primitive. They may not be how I dice up resources, because it still may make sense to have virtual machines for a lot of things. But containers are in the future how large companies are going to deploy applications. So the new world, in my mind, looks kind of like this. You have your infrastructure layer, and that's at the bottom, and it's just computers. They might be virtual machines, they might not be. On top, you have some kind of platform layer. I think CoreOS is pretty cool. I've been playing with Fleet a lot recently, so that can kind of like take your application and put it places, and on top, your application's running in containers. And what makes this work is this, like, it's back to like CS 101, interfaces, right? So the bottom layer is computers. Like, when I get a computer, I actually don't really care whether it's a virtual machine or bare metal. Like, if I can get computers that run my software, then people who can get me like better computers for a better cost, as long as the interface is a computer, I don't really care. I do my thing, and the guy who gets me computers does his thing, and in the end we end up like running at large scale and efficiently. And then containers are the interface for me to put software onto those computers. So I just like say like fleet control, like run, and it goes. And so this kind of brings me back to the servers. So we've got some flavors. I'll go more into those in a moment. But the thing that all of these have in common, I mentioned this earlier, and it's open compute hardware. So the hardware is basically open source, developed originally by Facebook. We've done some work ourselves on it. But the cool thing here is that instead of like me calling up Dell, and then Dell like figuring out what it is they want to build, and then they sell me and you and some other guys all like the same server, they slap a logo on it, and then charge me a lot of money. And Dell adds cool things too. But with this, basically, Facebook said, here's the kind of server that we want to use to run software at very large scale in a data center. And we're going to buy a ton of them. If you want to buy some of the same thing, call these people up and they'll make you one. So it's open compute, looks pretty cool. It does some interesting things with power distribution and so on. As far as networking, every server that we run is two 10 gig networks, or two 10 gig NICs. And so like where you're like, cloud server, you have like, is it 120 megabits? Is it like 500? I don't know. It's probably slow, and you may not actually get what it is that you're paying for. So here you're getting like highly available 10 gig networking. So there's two of them. If one switch goes down, they're connected to different switches. If one goes down, your application keeps on running. We've also got another for the way that we control the server kind of out of band. If you run interfaces, you see a ton of interfaces because we take the two sort of physical networks and bond them together, and then we put VLANs on top of those. So what you're actually interacting with is like these VLANs over here on the right, what's underlying it is these two physical interfaces. We have this thing called a SATA DOM. It's basically, if you were to like open up, I don't know, like a digital camera when they had those, and take out that little flash chip, basically they put these things onto a server. It's kind of all right, like you can boot up an operating system, like don't use it. Again, it'll boot the operating system, but if you like put your database on there, you're going to come to regret it. When you turn it on, what you see is basically you'll see like two volumes here. So the first is where your operating system is, and then the second is this thing called a config drive. And so the config drive contains a bunch of like JSON, and there's different files. It's kind of messy, but basically this is when you booted your server and you said like, this server's called Web 12, or maybe this was called CoreOS, I don't know. You boot it up, and we put that information into this config drive. And this is kind of a standard layout that various providers are using. And so the interesting thing here is that when your server comes up, you have all this JSON in there, and there's this thing called CloudInit. So if you install like Ubuntu, there's this collection of Python scripts that will attempt to do things to your server. So they do things like bring up networking, they kind of invented their own configuration management language. They'll do some stuff there. You can inject bash scripts. You can do a lot of stuff. It's a very neat concept. The software in question is really not very good. So the good news with all of this is that CoreOS basically rewrote CloudInit, and it does all of this for you. So you don't have to worry about like that networking jump there, because again, that's abstracted away. You're just running containers. You don't care about like how the NICs are configured, right? The interesting thing here is that the way that CoreOS is on CloudInit, you can use it to sort of run unit files, configure etcd, configure the way upgrades happen, and so on. And so when you boot servers, you can just inject a little bit of YAML that says like, hey, don't like reboot this computer out from underneath me because I'm still doing something weird on it, or only reboot one computer at a time. That's pretty cool. So as far as the specifics of these instance types, we've got our compute instance type. It's like got a CPU in it. It's got some cores. It's got fast networking. Again, it's designed for like if you're running, like a Ruby web app. This is kind of like the worker, the web node. So one thing that people do a lot of is like rendering templates in Ruby. As you can see, this is comparing it to kind of sort of equivalent Rackspace cloud server. We actually think our cloud servers are pretty good. So this is basically a comparison of like what is the overhead of virtualization. It's a little bit faster. It's nice. Memory one. Now this is where it starts getting cool. 0.5 terabyte of RAM. So who here has run Elasticsearch all in RAM? Who here has run Elasticsearch not in RAM? How much fun was that?
RAM is better.
Yeah, it's all right. I mean, it works. It's not super fast. It doesn't scale. Like, it's cool. Put it all in RAM. It's get really cool, really quick. Obviously, you're going to want some kind of like persistence. But so there's interesting things that we think we enable by selling 0.5 terabyte of RAM, and you can get this like in 5 minutes, and pay for it by the minute. So that's pretty cool. You get like a lot of RAM per dollar, basically. The I/O box. This one's also pretty cool. So the interesting thing here is that we have these warp drive EL something or other thing at the bottom. That's fast storage. It's got 128 gigs of RAM and some CPUs. Now this LSI Nitro thing. So basically, a while ago, disks were really, really slow. And so companies came along and said, how can we make disks faster? Flash is way too expensive for anybody to use for anything. But disks are way too slow to use to run cool things at scale. And so we'll take a little bit of flash and put it in front of the disk. And when you write to the disk, we'll put it in the flash, and later we'll move it over to the disk. And so these kind of tiered storage architectures came around. It turns out these have gotten a lot cheaper over time, and this particular model has some cool things. It's like Linux kernel drivers built in. It's really, really fast. And it's gotten so cheap that instead of using this as sort of a cache in front of real storage, so we're just going to take some of these and it'll be the real storage. And so they're really fast. So you get 2 of these things. You can configure them in a variety of ways. It turns out that ButterFS is it's pretty neat. It's not super fast. So what you really want to do is ext4 with MD RAID, probably RAID 0. If your software can't tolerate single disk failure, probably buy a different kind of server. I don't know. But this is where it gets fun. So there's other kinds of servers. These are nice. this is the really fast. Oh, sorry, these are the ButterFS ones. That looks a bit like what you would see if you were running this on a different kind of server. This is what happens when you do ext4 with MD RAID. It's really, really fast. This is not like a tuned benchmark in any way. It's just kind of like what happens out of the box. We also have a Postgres benchmark here. So also not super tuned. We just kind of like booted some servers, installed Postgres on them, ran kind of a generic-ish workload. We actually compared a Rackspace Performance 2 120, which is like the biggest cloud server. I don't buy them because they're like pretty pricey, but and we like DD'd some zeros on there because you're supposed to do that to make it faster. And then we have the one with the 2 PCI Express flashcards in the OnMetal one. It's a lot faster. So if you like have a database, you could kind of re-architecture like I'm going to shard it, I'm going to boot up a ton of these things. Like I'll use like whatever that Amazon thing configuration thing to like stamp out more and more of them, right? Or like buy one of these and just scale vertically as long as you can. So where does CoreOS fit in? So this is where it gets cool. So I mentioned that like this idea of the infrastructure underlies things. When you're running something like CoreOS, you don't care what the infrastructure is. So it's actually very important to us that we have things like CoreOS that make it so you can start running on a virtual machine somewhere. And then when you get to the point where you don't want to buy a tenth of a server anymore, you want to buy a whole fast server, you do this. And so CoreOS is supported. And so you can like today boot up a server in 5 minutes with a ½ terabyte of RAM or 2 really fast PCI Express flashcards on there and have it join your like fleet cluster and just automatically migrate things over. The other interesting thing is that this is actually built on top of CoreOS. So I mentioned that this is mostly based on OpenStack. So one of the components that we developed is called the Ironic Python agent. I'm not going to get too far into it, but it's an agent that we use to like put your code on the box. And that agent actually runs on top of CoreOS. So there's a variety of reasons that we did this. We think it's really cool because it enables us to basically quickly and easily build a Pixie image that we can just boot up on these servers and have code running in there, and like you can manage them easily. So it's pretty great. Before I take questions, I've got one more thing. So we actually have, if anybody was here 2 weeks ago, I did the same thing. We have some servers. Oh God.
Yeah. Are you giving these away for trivia questions?
And if we were, so the interesting thing is that if we were, I've actually got no way to power these because they take DC power to the back, so you can't just like plug it in like a normal server. If you want a whole rack, we'll tell you where to get one, but unfortunately, I can't give those away. Yeah, so come up, check these out later. Does anybody have questions? Yeah.
Are you guys using straight up Ironic, or do you have some secret sauce in there to make it work better?
So we are not using straight up Ironic, but the sauce is not secret. So we took Ironic and basically, so Ironic uses this kind of crazy iSCSI thing to do its deployments. We took that out, we wrote the Ironic Python agent that I mentioned, and basically that thing boots up and sits there waiting for a customer to come along. And when you say make me a server, we call to the agent, we say like put CoreOS on there and boot it up, and that's what the agent does. So all of it's open source. We actually wrote a blog post about how, like, all the code that we use and how to deploy it. We're kind of upstreaming all of this. It's all basically in OpenStack's equivalent of a pull request, hoping to get it all upstream and eventually make it the default deploy mechanism. But today, it's not just Ironic, but it's also not secret.
So maybe by Juno or the K release?
We're hoping for Juno. I think at this point, it's a little bit of a stretch, but we'll see. Anything else? Okay.
Why are the Satadoms good at sequential and bad at random? Shouldn't it be the other way around?
Anything else? Yeah.
How do you sandbox your instances so that they can't access things like firmware?
Right, so we're doing two things. So for firmware, we're using signed firmware, so like you can't write out your own firmware. We're also setting some settings that you cannot like access, for example, the out-of-band controller, and kind of do things in there that would either allow you to access another customer's instance or prevent us from taking it back from you. So it's mostly about the signing and then some kind of lockdown stuff. Anything else? Yeah.
What's the rollout schedule for OnMetal?
Soon. This month. Yeah, so anybody in this room, this month, we're hoping to allow anybody to actually just walk up and get one. Today, if you go to that URL, there's a thing you can fill in. We'll try to get you in, but no guarantees because capacity is kind of limited. So there's not. Cool. Thanks everyone for coming.